Okay, so welcome back to the DD Club. Today we're discussing the maximising the benefits of UVM. We're on with our third speaker and final speaker now, Malati from AMD. Her past experience includes working with leading firms such as IBM, Wipro, and the Gear Systems. She has experience in RTL design and verification of ASICs, FPGAs in the field of hard disk controllers, PCI, ARM-based protocols, SD-RAM controllers, and DDR memory controllers. She has facilitated and delivered several VLSI corporate training in the areas of system Verilog, UVM, OBJECTIONS methodologies. The abstract for her talk today, which is entitled Simplify for Reuse, is that with the ever-growing complexity of the chips, it is important to create a scalable and configurable verification environment which enables plug and play. Further, UVM is vast and open framework, resulting in inconsistent and non-standard solutions to similar problems. This presentation discusses some of the best practices to use UVM in developing a reusable environment. So I'm going to hand over to Malati now.
Hi everyone. So in the next few minutes, I'll be covering some of the topics. I'll be hitting the introduction, agent, factory, similar phases, objections, reporting, configuration, object, and sequences. So, well, I think so. We had already here gentlemen giving introductions about what is UVM methodology. So I would not be touching too much on this. Well, it's basically hybrid of technologies. It's nothing but an accelerator standard. Well, it's basically a culmination of Vericity's ERM, Mentors, AVM, and Synopsys VMM. And what is that we have here? We have a methodology which enables a verification environment to be reusable, scalable, and interoperable. Well, this is all great, but what is the problem? The problem is UVM is vast. Don't you think so? There is cookbook, there is reference manual, and then there is user guide, which is like, 500 pages of information out there. So most of us, for a given problem, we tend to have more than one solution, and we are confused about the fact which way should I use, or which method should I adopt for a given problem. And UVM is definitely great when it comes to reusability, scalability, and interoperability. But the problem with UVM is that you have too many options out there, and you're so confused most of the time which one to use for a given problem. So I will be focusing in this session about what are some of the best practices based on my past experience. So I'll just go over them with respect to the topics which I just discussed in the agenda. Okay, so given UVM agent, well, I wouldn't touch too much here. I'll just focus on the things what one needs to know. So UVM agent can be configured as a passive agent or an active agent. So most of you must be wondering, well, what is UVM? It's nothing but a base class library. It has all these libraries out there like UVM driver, monitor, agent. So most of us wonder, when there's already driver and monitor, why should one use UVM agent? Isn't it? So that has occurred to me also. So UVM agent, one of the biggest advantage is when it comes to portability. So when you use UVM agent, the biggest advantage with UVM agent is that it can be configured as active or passive. So what's the difference between active or passive? When you make the UVM agent as passive, only the monitor gets instantiated. When you configure the UVM agent as active, then the driver, monitor, and the sequencer comes into the picture. So when you want to reuse your UVM agent at the SOC level, most of the time your environment would be hooked to another RTL component, which will be driving, right? Generally, whatever block you're verifying would be hooked to another component at the top level. You would not be requiring driver and sequencer because the other RTL component might be driving the interface. But then what is that you would be needing is the monitor. So by switching it off, or by switching it off, by making it as passive, you could still use the same UVM agent, reuse the same UVM agent without having to modify any of the existing code. All you need to do is just control at the knob level. I mean, you just have a knob and then you just, enable the knob or switch off the knob. Okay, so that's the biggest advantage of UVM agent. Now, given a design specification, how do you choose whether I need to have, one agent, multiple agents? How many agents do I need to really have? So really ask me, well, given, let's say you're verifying for a block diagram. For a block, given a block, and you can definitely have one single agent to verify that block. However, if the block is very complex, then one agent would definitely become much more complex. So what you may want to do is divide that particular block into multiple interfaces, and then you can define multiple agents for a given block. However, you have to be aware of the fact when multiple agents are instantiated, definitely it becomes easier to manage, but you will have to have the knowledge about virtual sequences and virtual sequencers. The virtual sequences and virtual sequencers come into picture only when there is more than one agent. So if there's only one agent, you don't really have to take care of the sequences. All of it will be working on one single sequence item. But then you have multiple agents, each one of them will have their own sequence item, and then you will definitely need to have virtual sequences in order to drive these multiple sequences on the multiple agents. Okay, given the fact that UVM factory can be used to override or to basically make your test bench reusable, so what are the things you need to know? One is the factory registration, where you can actually register the components or the objects using the factory utils, that is UVM component utils or UVM object utils. And then by default, you need to instantiate the constructor in the component and in the objects. So how many of you are wondering here, why do you really need to have a component, constructor, right? If you generally see, you just write class myDriver extends UVM driver, and then you just have to have a base constructor, default constructor. And most of the time, the confusion is all about why a component needs to have two. Why do I need to pass two arguments to a component? Why do I need to pass one argument to an object? Now, if you really see, components are basically used to build the test bench environment. So if you want, if the UVM has to stitch the entire verification environment, it has to stitch the hierarchy, it needs to know the parent information. That is why you will need, only for the components, you will need the information who is the parent of this particular component. Whereas when it comes to sequences, it's not going to be a part of your test bench environment, right? It's very dynamic. So you can just allocate and deallocate. So that's where you don't really need the parent information. Now, what is that you need to really keep in mind here? Well, when it comes to factory, most of the time, people are confused when they actually create the objects. So if you see here, how do you create the objects? So have driver, myDriver, type ID, create. So one thing is, most of them think that, yes, create is basically there, then why can't I use new? Well, create, it's definitely the same thing as new. Only thing is, create calls the information or gets the information from the factory. Okay? So factory is nothing but a database or a built-in library which is available. So in here, most of the time, what is the name you pass here? So is it that significant? Yes, definitely it is significant when it comes to debugging. So the recommended practice is to keep the name of the driver, whatever string name you're passing via create, keep the same name as your handle. Most of the time what I have seen is people keep the same name as the class. Now what's the pitfall here? The pitfall here is, let's say you're going to create the class, many number of classes, many instances of the same class, right? Then it will take the same name for all the classes. However, it's not going to affect anything that works logically or functionally out there. But then when it comes to print topology, right, The print topology, whenever it prints the hierarchy for you, it takes this information from whatever name you have passed and then it prints the topology. So definitely this is a recommended thing so that it will enable you for one is readability, another one is debuggability. All right, coming to modeling stimulus. Well, what are the ways to model a given stimulus? One is, okay, so when you're modeling the stimulus, generally what you do is you have class my item extends UVM sequence item, and then you basically add all your properties, right? And then you register them to the factory. The reason for registering them to the factory is to basically use the built-in methods such as copy, compare, print, pack, unpack, all these built-in methods. Now, most of the time, we do have two ways of doing this. One is we have UVM field macros, okay? The other one is you can actually achieve the same thing by overriding the methods. So, which one do you prefer, right? So, one thing is, first thing which I really want to prefer is the UVM field macros, because I don't want to go ahead and manually override the method that is given. If somebody has given me something which is easier, why not use them? But then there is a problem with this. What is the problem? It definitely affects the performance, the runtime simulation performance. So how does it affect? Well, every time you call these macros, what happens is it unfolds into many lines of code every time you run the simulation. Okay? So what happens is this definitely has a significant impact on performance. Okay? So now, would you ask me then what is the use? Why do we really have those macros? Well, if your verification environment is smaller, right, go for the easier approaches or easier methods. It's always, easy to go ahead and use them. But then with the complexity of current designs what we have, definitely what I would suggest is, go ahead with the override method. But then, what is the advantage with override method? Well, if you see here, if I override, of course, it's just like one-time investment. At the starting of writing your verification environment, you go ahead and write manually all the methods, whatever methods you want to. But then each time it is executing or running the simulation, definitely there's a big savings. Why? Because it's just going to run your code. But earlier, when you're using macros, what happens? Every time you run the simulation, it will unfold into many lines of code. Right? So definitely that's a big difference which you can see. So again, as I said, if it is a simpler and a smaller verification environment where you're using, where you don't see performance is such a challenge, definitely you can go for the macros. But then if you see that, you may want to save everywhere, every small thing, you want to really save on the performance or you want to save on the simulation runtime, definitely this is one thing which you can keep in mind. Okay, to UVM phases. In UVM, what we have is, we have a series of functions and then a task, a run task, and then again a series of functions. So basically these methods are called during the start of simulation, and then you run the simulation, and then basically this is post-simulation, post-start. Now, the run phase, so this is basically so if you really see, right, this was actually whatever we have right now in UVM is backward compatible. Most of them, at least, are backward compatible to OVM. Okay, so the run phase was already there in OVM. What we have new in UVM is, if you see here, I have these run phases, runtime phases. Okay, so if you see here, I have 12 subphases. Now, you could use them or you could use the run phase. Well, if you really see, if it's a simpler environment, right, where you don't have complex functionality like you want to jump the phases, right? Like, for example, let's say when I have a reset, I want to go back and, call my reset phase, and then I want to call my configure phase again. So, I recommend this is not just a recommendation from me, definitely it's a recommendation from UVM forum that do not use this run phases. Okay, if it's a very simple environment where you have configuration phase or the reset phase and then the main phase, then you're free to use them. But then as long as there is no complexity. Okay, if however However, I would still recommend using the run phase what we have for better controllability and debugability. Okay, so if it's a simpler environment, go ahead and use this. And if it's a little complex, always better to have control within yourself and then add the code within run phase. So just to see here, right? So I've just, I just have a couple of things here. Yeah. So come back here. I have just highlighted. I know Mike has already, mentioned about UVM 1.2. So I've just added a few snippets here and there just to highlight what has been added in UVM 1.2. As Mike mentioned, in UVM object, right? Earlier, what we had in 1.1D, we did not have to really call the constructor. But now it's a must that you have to call a constructor. That's something which is newly that has been added. And then factory can be overridden. In UVM 1.2, till 1.1, we could never override the factory. So in UVM 1.2, we can override the factory and add your own factory details. Well, when it comes to phases, these are some of the things that has been added, like phase.get adjacent predecessor nodes, adjacent successor nodes, set jump phase, and end prematurely. So these are some of the things that has been added with respect to the phases. Yeah. Yes. Right. Well, they are given to you as functions. Okay, they're not given to you as tasks. Generally, what happens is you check and then you basically extract the information and then you do the checking of the information. So it's all at zero time after doing the run of the simulation. However, you can collect the information during the runtime and then you can, evaluate them at one shot. That's the flexibility you have here. If you want to do a runtime like on the fly check, the best way to do that is using a scoreboard. Absolutely. Anything time specific has to go to?
Repeat the question for the people.
Okay. So, yeah, the question is, shouldn't the functions, the post-run functions like extract, check, report be tasks so that, during runtime we can add checks, right? So, well, as I said, this is given to us by the forum. Well, if something you want to add checks during the runtime, you can always use, if you're using subphases, you can always push it at the shutdown phase, right, after the main phase, or on the fly checking can be done using the scoreboard. Okay, coming to objections. Well, I think all of you must be aware of the fact that we can raise objections in the components and we can also raise objections within the sequences. Now, coming to raising objection and dropping the objection. So what is that is recommended? Well, to really see, any sequence cannot start by themselves. All you need to do is call the sequence within the given test case, right? Or you can calling the set default sequence, right? So if you come here, I can call a given sequence using start, okay? Or I can use the set default sequence. Okay? Now, what's the difference? When do I use a default sequence? When do I use the start? Well, the recommended practice is to use .start because you can achieve everything whatever you want to achieve. But there is a limitation on the set default sequence. Set default sequence can only set one single sequence for a given agent. Okay, so what it's not that you cannot achieve the same thing with set default sequence. What you could do is you can group all your sequences, push it into one virtual sequence or another sequence, top level sequence, and you can set it as a set default sequence. However, your agent will be tied to only one sequence. However, the flexibility with using the .start, right? So what happens here is you can create as many tests as you want and then create as many, you can call as many sequences you want for different scenarios. So that's the advantage. So I would definitely, recommend this, but I'm not saying that you should not use this. Definitely you can use it as long as you just have one sequence to control within a given UVM agent. Okay? So coming to this, well, Mike iterated here, starting phase, what we had in OBM or UVM 1, even before 1.1D was we had starting phase and starting phase dot raise objection, starting phase dot drop objection. What we have in UVM 1.1d is that these two are guarded. Why are they guarded? Well, earlier what used to happen is, whenever I raise and drop objection here, and let us say I had raise and drop objection within my child sequences, what used to happen is it used to never set those child sequences unless I go and manually set. So they guarded it by actually setting, by introducing a new method called as get starting phase and then set starting phase. Okay. So coming to this, well, there is also one more thing that has been added in UVM 1.1, that is set automatic phase objection. All you need to do is set that to 1, and automatically what happens is it basically raises and drops the, it basically not raises, it basically sets the starting phase automatically to the default sequence. So who basically sets the starting phase, by the way, is the default sequence. When you do a default sequence, it automatically sets the starting phase to the phase wherever you're calling this particular sequence. So no, it is for the default sequence. Okay, so you also, generally, right, set automatic, that is only in conjunction with this. We generally don't need this, right, here. So if you really see, most of the time people think, okay, in the cookbook, in the user guide, or even in the forum, right, when you see sequences, generally see raise objection, starting phase dot raise objection, starting phase drop objection, and you generally go and add blindly there, right, not realizing that how much impact it has on the performance. Okay, if you really see, most of the time you don't need to raise and drop objection within the subsequences. All you need to do is raise and drop objection within the parent sequence. So the same thing can be achieved when you're actually raising and dropping the objection within a given test. So all you're doing is you're raising one objection and dropping one objection. So one thing you need to realize is raising and dropping objection is definitely going to be a little bit of overhead on your performance. So in every sequence, if you're going to keep, raising and dropping the objection, so then that's going to be a big impact on the performance. So coming to reporting, well, when it comes to reporting, we have reporting methods and we have reporting macros. So earlier when we started using this, we started with UVM reporting methods, most of us, right? And then we moved on to use UVM macros, right? So what is the advantage? Why should I use, the recommended thing is UVM macros rather than UVM reporting methods. So what is the advantage of UVM using macros, reporting macros? The biggest advantage with reporting macros is again the runtime performance. There's a big runtime performance. What is the advantage? Well, in reporting macros, if you have closely observed, warning, error, and fatal, by default, they all have the verbosity as UVM none. Okay, so you do not have the flexibility of changing the verbosity. However, with UVM info, you can change the verbosity. And not just that, the line number and the file name automatically gets displayed when you call the macros. With respect to UVM methods, you will have to pass the line number, the file name, and all the remaining information with the verbosity settings. Now, what is the advantage? Because most of the time, what I have so far recommended is do not use the macros, right? But whereas only here I have said, yes, it's a good thing to use the macros. The reason being, it automatically displays line and file name, and also the code is written inside in such an optimized manner. It has a better way of handling the reporting messages. What happens here is when you pass the verbosity, whatever settings, right? It actually is handled by UVM report handler, which passes through the information, and that actually affects the performance. So in UVM 1.2, as Mike again as mentioned in the morning, so you will see that UVM, there is a big change that is coming in UVM 1.2. It is object oriented. Most of the time, if you see with UVM macros, what happens is when you display, right, you'll either have to move all the way to the right side of your, text information, text file, and then you have to really look at the message. Most of us have done that, right? So what happens is the first half of the message would generally be the line name, file number, all those things, which most of the time we are not that interested all the time, right? We want to look at the message which is being displayed. So in order to avoid that, if I can group list of messages within a given verbosity, it becomes easier for me. So that feature has been added in UVM 1.2. If you really see here, I have UVM info begin, UVM info end, and I just set one tag or verbosity to it, and then I display whatever I want to. So that's the biggest advantage in UVM 1.2, wherein you can group all the messages and then put it under one verbosity setting, and then you can display the message. So that way it will display all the information, and then the remaining information is displayed in the tabular form. So what is that you need to really, take care by writing the configuration object. So the biggest advantage of configuration object is to basically you identify all the parameters in your given environment, and then you basically go and add it inside the configuration object so that it can be configured or it can be used by the person whoever is using your verification environment. Okay. So what happens is normally the virtual interfaces, I'm just going to focus on the virtual interfaces. So given an environment, typically how do you actually access virtual interface? Most of the time what we do is we push the virtual interface right into the configuration database within the driver or within the agent virtual interface. Okay. Now the recommended thing here I have is, let's say you have a series of virtual interfaces or many instances of virtual interfaces, right? So what we can do is we can group all of them and push it into the configuration object. Okay. So what is the advantage of actually pushing all the interfaces into the configuration object? The advantage is that, again, as and when you are actually accessing the configuration database, definitely there's again a performance overhead. Okay. So when you keep accessing the configuration database, there's again a performance issue actually. So if you see here, what you can do is you can put all the virtual interfaces inside the configuration object. Anyway, your driver, monitor, agent, anyway it will fetch the configuration object from the database because it has to get access to the remaining parameters. So along with the remaining parameters, you definitely get a virtual interface instance. And then what you do is, you see here, I use a get and then get the configuration object, and then I assign the local virtual interface using the configuration object interface. So this is another advantage wherein within one get from the database, you get access to all the parameters including the virtual interface. So how do you do this? So if you see here, I have the DUT here and I have the interface. Well, what you need to do is within the top test bench, you actually push the virtual interface inside the configuration database. Within the test, you get that virtual interface and assign it to the configuration object virtual interface. And then again set that particular configuration object back into the configuration database. Now, within the corresponding agent or the driver, what you would be doing is just you will get the configuration object and get access to all these parameters. So this is one thing which you need to follow when you're really setting the virtual interface within the configuration object. Okay. So within the given, okay, this is another thing which I have with respect to configuration object with respect to sequences. Most of the time we do have parameters sitting inside the configuration object which I would need to access from the sequences, right? So from the sequences, how do you get the configuration object? You will again use UVM config DB and then get, you see here, the path we would use get full name. Why? Because your sequences is never part of your test bench hierarchy. It can only become a part of your test bench hierarchy through the sequencer. So when you use get full name, what get full name will do is that it will get the hierarchical path of this corresponding sequence. That would be with respect to your sequencer. So what it does is it will go and fetch the configuration object from the sequencer hierarchical path. So this is one thing which you have to remember while actually getting within the sequences. Most of the time what people do is they have a sequence, they get the configuration object within the body, and then they say, if you see that I have another sequence which calls this as a subsequence, and then I say repeat 100 times, and then I do start this particular. So I'm actually calling this 100 times. I want to run the sequence 100 times. Now what is the problem you see here? Getting the object, whatever configuration object from the database 100 times. That's a big performance issue again. So not, I mean, it may be intentional or non-intentional, but then you have to either rearrange your code, how to achieve the same thing with less performance issues. So how do we do this? Well, you can call this, getting this configuration object can be done once at the start of the simulation. Okay, and then you can actually pass that information to the subsequences. Right? You don't have to call, because configuration object, unless, I mean, most of the time it is used, it is only changed during the start of the simulation. Unless you're changing somewhere in the middle, you need to take care of that. So with respect to configuration object, what we have is, we have a UVM enum wrapper that has been added. So earlier in UVM 1.1, we could never set the, or we could never initialize the enumerations. Whatever enumerations you have, you could not initialize those enumerations through the configuration object. But with UVM enum wrapper, you can actually initialize through the configuration object. Coming to sequences. Now, what is that we have with respect to sequences? How do you write the sequences? One is we have these macros, very easy to use. The other one is we have these methods, start item, finish item, and then the what is it? And then create. So all these are the basic built-in methods. Now these macros are actually written using these methods. Okay. So if you really see, if I just go into the basics of what is the handshaking mechanism between the driver and the sequence, always through the sequencer. So if you see the basic handshaking protocol here, the sequence actually puts a request using the start item, and then it blocks. By the way, start item is a blocking method. It blocks till the driver acknowledges it. Okay. So what is the driver? So first thing is, then who is the initiator here? The initiator would always be the driver here. Okay. Why the driver? Because that is, the driver is the one which says, okay, I'm ready to, send the data on the protocol. So get me the data. So what happens is, the first step is the driver actually puts a request using the get next item to the sequence. Okay. And then that is through the sequencer. So, and through the sequence, you basically start the item, or you kind of, say, I'm ready to send you the item. Okay. So once it gets get next item request, the sequencer acknowledges the start item. Okay. So then what you could do is, you can randomize, and then you can say finish item. Using finish item, it actually sends the information, the randomized information to the driver. Now, it is again a blocking task function. I mean, it's a blocking task here. It waits for the driver to acknowledge. So how does the driver acknowledges? By calling the item done. So it calls the item done and says, I'm done. You can go ahead and do the next task. Okay. So this is the basic protocol what we have. Now, if you see here, right? So this whole thing can be achieved using pick UVM do, right? But then, if you really see, again, it comes back to the same thing. Using pick UVM do, it's very easy. If you see the code, right? It's just, I just need to call one macro and then I'm done with it. It will call all these steps. Again, there are certain hidden things which you are not aware about these macros. One is, UVM macros do not call the pre-body and post-body. Sorry, yeah, it does not call. See, for a given body, right, and for a given sequence, you have pre-body, body, and then the post-body. UVM does not call the pre-body and the host body. It goes and calls directly the body. But then it's very easy to use, and I have used in some of my simpler environments. I would not rule out that you should not use them. Yes, definitely it's very easy. However, I did see some issues while debugging. And when I was trying to debug, it took me more time because it was something internal to the macro, and I could not understand what was going wrong the whole. Okay, so coming to this, if you see here, I feel this is much more simpler and easier for debugging purpose. You know what you're doing. So what you'll be doing is you just be adding start item, randomize, and the finish item. Okay. So in this case, what happens is, you know, if something goes wrong, there is only 3 steps over there, and then it becomes very easy for you to debug. If something goes wrong with the macro, right, it's not very easy because we do not know how exactly it has been implemented inside. Okay, so when it comes to simpler environments, it is still okay to use this macros. This is only from my whatever my experience. I still find it very handy when I have to, you know, quickly come up with a sequence with these macros. I can just call them and just run them. But then when it comes to complex environment, right, so when it involves too much of debugging, that's when I prefer using this method. So as I said, there is no like hard and fast rule that you have to use this or you have to use that. Based on your requirements, or based on the design requirements, or based on your past experience, you can actually go ahead and see what is the consequence of using one approach over the other. So what we have here is one thing which we have in UVM 1.2 with respect to sequences is that we have UVM set default sequence. So with UVM set default sequence, you can actually go, earlier what we used to do is we have to go inside the test, and normally we set the default sequence within the test. But then user would want to control passing this or setting this default sequence using the command line, right? So then that's when you generally, you know, say, why don't we have an option? Well, that has been added in UVM 1.2, where you can actually set the default sequence using the command line. So, well, these are some of the, I know it's, I just touched over some of the best practices or best methods that can be adopted based on my past experience. I hope this helped some of you, and all these, whatever slides I have prepared, it is taken from UVM cookbook, and then I've just brought in my experience for these slides. Thank you.